And then we press the go live button and hope everything works. Oh man, a little bit late today. A little bit late. Decided to do the stream very late, like 5 minutes ago. So we'll just give it a second. Sync. There we go. All right. The couple of things. I started doing typist for all the Rust Adventure workshops. This is the Flappy Bird workshop at the moment. It is just a straight port of some of the markdown files that I had, but it's very cool to see like it in PDF form. I feel like this gives me a much better overview overall of what actually is going on and allows me to get quicker feedback on it, which I'm very excited about. And then this will also get like distributed as part of the platform, which should be pretty cool. It looks a little bit weird in the formatting department, but overall relatively happy. Love Typist. Typist is doing really well for me at the moment. I just switched my entire blog over to it. Let's see if I can pull this up. So this is my personal site, and we end up with all of these are now Typist posts. I converted all the markdown, all the old markdown stuff. This is Typist now. Got a nice little web view transition. This one just happens to use the outline in the beginning, but I think I'm going to move the outline to like a sidebar on the right. But this is all Typist, which is great. These notes are Typist. This is how it's written in the actual document that wrote this page, which is very cool. Couple of the downsides, I don't know, my lib.type is getting pretty big, but we'll see. Very happy with Typist overall. I think that it's giving me a lot of energy to write more, which I really enjoy. That's the personal site. So I think right now, I can't get IK out of my head right now. So I think that one of the things that I want to do is each repo clone, Rust Adventure, Bevy examples, IK, I guess, inverse. What do I name the repo? Bevy examples, IK, I guess. I don't know. I end up having so many copies of different repos. Just because I have so many ongoing PRs at a given time and I don't want to stash them. Maybe that's something we'll do at some point too. We should look into JJ. Maybe JJ would give me a better... JJ is Jiu-Jitsu, for anybody that isn't aware already. Jiu-Jitsu is a... I don't want to like call it like a layer over Git, but it's kind of bootstrapping itself by being compatible with Git, is my understanding. They just had a release very recently. A lot of people that... Good morning, I really like your streams for being so calm and straightforward. Awesome. That's great. I loved hearing that. I'm not a person that gets super amped up all the time. So portraying that would be hard for me to maintain over a long period of time. Yeah, so JJ is Jiu-Jitsu. It's Git compatible, version control. A lot of people who I respect have been very interested in Jiu-Jitsu for a while now. There's a couple of interesting tutorials. I think Steve FABRIK, JJ. Steve FABRIK has written quite a bit on using JJ, like from a beginner's perspective. So maybe we go through some of this in a stream next week. But yeah, very, very interesting project. They just did a release. There was a couple of fixes and stuff, but nothing too exciting from what I saw. But I'm still using Git, and I'm still cloning new repos all over the place because that's the way my brain works, I guess. If I don't have an open repo cloned with a PR in it, then the PR like doesn't exist in my brain. God forbid it like sticks into the Git stash, you know? Like I do a Git stash whatever, and then it's just gone forever. I never look at my Git stashes. Like, I don't even know that I can, is it list? I don't even know that I can list my Git stashes. None of them are named, so it's not like I would be able to find anything in there either. So one of the things that I'm interested in doing that I have no experience with, and I don't know if it will be successful or not, is inverse kinematics. But I can't get it out of my head because it's one of the things that I need to do for the skiing demo. Specifically, I want to do some inverse kinematic legged spiders for some enemies. I don't know if it's going to be spiders or if it's going to be like little turrets, like 4-legged turrets or 6-legged spiders. But same thing, right? Like stable core, 2 bones, and a foot placement. So I figured I might start with like a 2D IK demo where you stick the mouse on the screen. We've got a 2D Bevy app of some kind with 2 lengths of lines, maybe gizmos even, and just get it to kind of extend towards the cursor at any given time. If it's past the cursor point, and bend to find the cursor point inside of sort of like the reach of the sphere. And from my understanding, the method for 2 IK bones is basically analytical and boils down to like Pythagorean theorem and stuff. That said, I've never done it, so we'll see if this works out for me. I don't have a particularly strong math background. I guess I would say like I went through high school, did calc in high school, and then math kind of stopped for me at that point, and anything past that I've learned on my own. So any linear algebra I know, I've learned from like 3 Blue 1 Brown videos and things like that, or doing like random experiments. You say FABRIK is really easy. Okay. I was under the impression that FABRIK was a little bit more complicated, but maybe easier than other approaches. So maybe we take a look. FABRIK is a paper, right? Maybe we take a look at FABRIK before we start implementing anything. Forward and backward reaching inverse kinematics is FABRIK. So before I even create the project, let's just take a look at FABRIK, if we're getting the suggestion to do that. Did you successfully implement FABRIK, Forex? Or are you just kind of like getting into it? I guess if we do fabric, we could do theoretically multiple bones, which would be cool. I don't really need multiple bones for the implementation of the enemies that I'm thinking of. So I think the kind of like triangle vector decomposition into basic vectors kind of approach would work. But fabric could be cool. I'm never going to have more than like, I don't know, 6 of them on screen at any time. So I'm not really too concerned about the cost of the algorithm. If I was building, you know, Megabonk, I might be more concerned about it. It's really good if you need a relatively easy implementation and don't need NASA-like accuracy. You didn't implement it, but it should be fairly doable. Cool. Okay, we don't need NASA accuracy. We're not trying to land any spaceships. Maybe one day. Yeah, we're not trying to land any spaceships, so should be fine. There's a couple of papers here. Final IK. Ooh, they have the bib text. I can do this now. Ready? Here's the bib text. Let's go to bib text to Hayagriva. Dump this in here. Copy the output, and if I can find the desktop that things are on, then this will work out very well. And just dump this in. And now I have the ability to, I kind of like everything lowercase, so I'm going to lowercase this stuff. Maybe I should keep FABRIK uppercase. I don't know. It's an acronym, but this is my internal ID for it, so it doesn't really matter. So I'll make this like the top level FABRIK bibliography link. And now whenever I reference it in some post, which I'm going to do, having done some research and whatnot. I think I deleted my GJK post when I was converting everything, unfortunately. Let's have everything I need. Perfect. We'll just call this inverse kinematics. I don't know what the actual name for this post is going to be. I don't know what we're going to get to today. I don't know exactly what's going to happen here, but we'll figure it out. No byline yet. I guess we can just stick the image URL to be default. This is my typist test post, is what this is. So cool thing about the typist stuff, if I do just watch, that would build the entire site, which is very cool. So this is like building the entire Leptos site and whatnot. So if I pull this window over here and I go to localhost 3007, this should show up here. Oh, I don't have it published. Hang on. I forgot that I haven't implemented draft posts yet. So if it's not published, it doesn't show. So inverse kinematics, this is now like the typist test post actually, with a bunch of code blocks, lists and stuff like that, figures, tables. Here's a footnote, term lists, quotes with attribution. Here's a bunch of notes that I implemented that I kind of pulled from previous stylings, which is kind of just written as like hash note, which is really cool. And then here's my references down here. So like this is how it will show up in a post if I use it as a reference. That's very cool. But the other thing that's very cool is I have this watch post command. And this watch post command lets me, assuming that I did this correctly, Oop, I had it on a different monitor, that's why. Oh, please, while I figure out whatever I just did. I think the PDF like glitched out. I think the application is glitched out right now. Preview is glitched out. Hang on. Let's quit preview. That was mildly hilarious. So inverse kinematics. Let's go back over to our blog page, or I guess, yeah, I don't know. It doesn't matter where we do this. Yeah, let's put it here. And now as I'm writing, the whole thing shows up in a PDF. So I've got like PDF hot reload for all my blog posts, which is very cool. Yeah, I don't know what just happened. That might have been the window manager. That might have just been preview. It like jumped from being like a docked window on the second half of a full screen monitor over here to being wherever. And we get like super nice formatting for all the quotes and stuff. It gives all the references. Footnotes get placed in the right spots. I'm really enamored with Typist right now. I'm really enjoying the process of using it for writing, which is what my most recent blog post was about. So I can write now in like web form or in PDF form. You're not entirely sure if you want to watch it on stream, but there's a video explaining the algorithm on YouTube by Ego Moose. I will note the video down and watch it later, is what I'll do. I may or may not have great success doing this. Inverse kinematics. I may or may not have great success doing this, but let's grab the actual URL. There it is. But I will keep this around for later, and now I can use it as a reference. I'm so excited about references. You have no idea how excited about being able to have references on my site I am. Ego Moose inverse kinematics. Good morning, Anas. How are you? So let's check out the paper, FABRIK. YouTube was briefly upset with me. Okay, so forward and backward inverse kinematics, iterative approach to solving inverse kinematics. We'll just go from the start because I don't know much about FABRIK. I know it exists. I haven't used it. So we'll just kind of start with figuring out what FABRIK is, reading through the paper a little bit, reading through, I guess this is a presentation on FABRIK, so maybe it's not the original paper. I don't actually know who the author of the paper is, but it looks like this person, right? I think it is this person, but clearly we're seeing like slides, not a paper here. Okay, determining the joint parameters or degree of freedom to provide a desired position for each of the end effectors. So effectors are basically like this thing where you pick a target and that target is called an effector. I don't know why. And then the inverse kinematic is kind of like figuring, so if you have like two bones, right? It's the inverse kinematic is figuring out what the angle of those two bones needs to be to put the end at that effector. There have been other examples that I've seen of, let's see if I can find one quickly. Inverse kinematics. I don't know, demo. Maybe I won't be able to find one very quickly. Spider. Spiders are really popular with game dev people. Oh, there's a FABRIK implementation right there. Maybe we'll just keep that open for later. I'm looking specifically for the effectors visualization that people use. Looks like this person's using boxes. Not seeing any of the others have what I'm looking for here. Oh, look, this week in Bevy. As if these search results weren't personalized. Okay, so basically effector is like that end target position. And we have to figure out the angle to put those two bones at from the effectively stationary body to that end effector. Stream's going pretty well in us. Stream's going pretty well. We just started, I think, a couple minutes ago. Got kind of distracted talking about different stuff as usual. And now we're doing inverse kinematics because why not? So, hey, Fioscos, how's it going? So one method is to model the problem as like gradient descent, or not gradient descent, but the cyclic coordinate descent, yada, yada. Other methods suffer from problems. Is this the algorithm for FABRIK? Forward and backward pass. Maybe not the best to start with the slides here. FABRIK with multiple end effectors. So here's a bunch of end effectors, sub bases, root. That's cool. So you can kind of like pick positions to move through for different end spots. So I'm going to say this is the algorithm for FABRIK. Given joint positions for I to N, target position and the distances between each joint. So we've got the effector, is my understanding, and the distances between each joint, which will be, I think, hard to come by just doing like a Blender export. I don't think we get like the length of the bone. That is something that I need to figure out a little bit. Hey, Tony, how's it going? So total distance is kind of the max reach distance, right? I think that's what they're saying here. Distances between each joint, DI. So total distance is DI. Is all of the points positions for all of the points. This feels like a weird way to write that, but you know, I'm not really a math reader, I guess. I wonder which algorithm my brain uses to move my body. Oh, that's easy. Mine turns Monster Energy into Bevy tutorials. That's what mine does. P1 minus T. So P1 minus T. So if a point minus the target position. So point minus target position. That means point has to be less than target position, right? So we'll say this is like a 2-bone IK system, and we're talking about the joint that connects the two bones, right? So if the joint that connects the two bones minus T, which would presumably mean, so like body of spider, this is the vector from the joint position to the end transform. If that's greater than, no, that's not the vector, because we're going to add up all the distances. So if that joint minus the target position. So that middle joint minus target position. So if the target position is too far, then we end up with a positive vector. I don't think that's true necessarily. Might be. That's how I'll frame it in my head. If we do this, we'll end up with a positive vector. If it's within that distance, then it's a potentially negative vector. It's vectors. P1 minus T, the total. Yeah, it definitely is vectors for sure. Is the total distance between the start bone and the target position. Oh, P1 is the start bone. P1 is the body root. Okay. P1 is the body root. That's why. For some reason, I was thinking like, I thought this was PI for some reason. That's what I was thinking. So I was like picking an arbitrary joint in the middle and being like, okay, how does this work? If that's the root, then that is the body of the spider, like the attachment point to the spider. So that makes more sense. If the let's see, sum of all the lengths is less than the distance to the target, you can't reach it. Right. That I intuitively understand. I'm just trying to understand their syntax. Right. Lengths between each bone, position of root bone on spider minus target position. So is this global space? World space? Right? Because otherwise position 0 is 0, right? So if we think that this is like, I don't know, leg local space, we'll say, then this is effectively 0. And we've got negative t is greater than all the distances added up. So t is greater than all the distances, I guess. Because then this is just a vector to t, right? Which makes sense. If it's global space, then we're recentering. Okay. So find the vector, find the relative position of each point along the vector, yada, yada. Otherwise, the target is unreachable. So basically, if we have the lengths, then we can determine easily if it's within reach or not. If it's reachable, we get to the interesting part. Set B equals P1 as the initial root position, which is our root bone attached to the spider. Find the distance of, is P1 the root? I feel like we're supposed to be going the other direction. I feel like P1 is supposed to be from the effector to the first joint, like from the effector's side. I guess they have a forward and backward pass, so we'll figure it out. Find the distance of the end effector from the target. While diff is greater than tolerance, perform forward and backward pass. So the forward and backward pass is really the interesting part here, because otherwise all we're doing is going from joint to joint and performing the forward and backward pass as we cover each joint. Yeah, P1 does seem to be the furthest away from the target. It does seem to be like that root node on the spider. So the forward and backward pass, move the end effector to T. Move the end effector to T. Did I misunderstand what the... end effector is the last joint. Okay. For some reason, I thought the end effect or the effector was going to be that like target position, but they're using target position and end effector to be the last joint, like the tip of the bone, which is interesting because I feel like if we export from Blender, let's say, what we end up with is effectively 2 transforms for a 3-bone system. We end up with the root that's attached to the spider, and we end up with that middle joint. And then I don't actually think we get like a final joint. So we'll either have to make a final joint or figure out how to handle that. So vector, move the end effector. Do we update the end effector? For each of the previous points, do something. Now our root will be somewhat shifted. Okay, so this is moving backwards effectively. So we move the end effector for each of the next points. Find the vector in the new position relative to that joint. Update the new diff. So I guess we're treating, like we're iteratively moving backwards from the end for this end effector. There can be multiple possibilities for the middle joints, but the last one needs to be at the target. Yeah. I mean, like if the last one can't be at the target, we can't do the IK, right? Otherwise, it's just like a straight line from, you know, root bone to the direction of the target. My thing is, it says move the end effector to T. But it doesn't describe updating that end effector. So let's see. So this is A and B. Theoretically, T is the target. P4 would be the end effector here. That gets moved to T, and then presumably this is the algorithm in action. You think if you draw it, it's easier to understand? They do have drawings here. I wish they were labeled drawings. But we have to do this forward and backward pass multiple times. Is the thing that's tripping me up at the moment. So it's unclear to me whether that's like one pass or multiple passes. Right? We've got some chain of bones and a target. So we move the end effector to that target as step 1, right? That is move end effector to target. Then for each of the previous points, find the vector pi plus 1 minus pi. As the relative position of that joint along this vector. So they kind of like move in towards the vector line here, I guess. No, they move towards the vector between themselves and the target. Okay. So P3 moves towards P4, P2 moves towards P3, P1 moves towards P2, at which point P1 has moved, and now our root is shifted. Right, that's this little shift here. And then this red one has to be set P1 equals B. So we set the root back to where it's supposed to be. So that is this set. And then we have to recalculate. So this is the backward pass. So we recalculate that. It moves P a little bit. But I guess hopefully not enough to matter. Is that the idea? Or is this multiple passes? That seems pretty, I don't want to say pretty easy to implement. It seems pretty reasonable to implement. We'll put it that way. The last step in the forward-backward pass is update the diff, and the slide before says while diff is greater than tolerance. Yeah, so there's an iteration here. Yeah. So this is one pass, effectively. And then presumably we do this until the tolerance is achieved for both of the root and endpoints. Well, that seems pretty reasonable, honestly. Let's build some 2D gizmos. And I'll try to keep this on screen while we do it, I think. Let's do cargo examples. Let's call this inverse. I always forget whether I name these with dashes or not. They are dashes. Inverse kinematics FABRIK. That's what this is called, right? FABRIK. 2D FABRIK. So we should have inverse kinematics 2D FABRIK main. So this obviously needs to have Bevy as a dependency. So let's get Bevy in here. Well, it doesn't need to have Bevy as a dependency, but like, what else do we do on this channel? Bevy.workspace equals true. So we'll do a use Bevy prelude. We'll do an app new add plugins, default plugins. We'll do a add systems startup with an add systems update.run. This is actually how I write code, so I do legitimately just pin a 300 character line and then hit save. I did not know you could do that dot syntax in TOML. For, yeah, the dependencies. Yeah, it's really nice if you don't have to specify any of the features or anything. I feel like it gets in the way if you end up needing to specify features, but, you know, I think more often than not, I do end up actually using .workspace without any additional stuff. So really what's happening here is we have all the dependencies specified at the workspace root, and that has a set of expected features like file watcher. So whenever we use Bevy inside of any of these crates, file watcher is always enabled, which is just nice because otherwise I'll forget. Sorry, what is AK? AK is inverse kinematics. The idea that you can have like a target point and a set of bones, and you want the end of that target and the end of the bone chain to be in the same spot. And how do you figure out how to make that happen? That's inverse kinematics. It's probably only useful for workspace. Maybe. I've never tried it with anything that wasn't workspace, if I'm being honest. Like, I've never tried, like, but we already have the shorthand for version. I can't think of anything else that I would put here. So I think it's only useful for workspace, yeah. Let's get startup in here. We're going to do some spawning, I think. I think we're going to do gizmos, like asset gizmos. I don't know yet. I haven't decided. This is going to be I don't know, a query for some root bone, right? Let's see. So we're going to spawn something here. This is going to have some kind of like IK or like do inverse kinematics. Terrible name for a component, but I guess because this exists, we don't need do in front of it, but we'll just call it inverse kinematics. So we're going to spawn this in. It's going to have a couple of things. One of those things is definitely going to be the inverse kinematics component. Another is probably going to be a transform of some kind. We'll just make this default. We'll stick this in the center for the moment. This is also going to have children, right? So this is going to be, and these are going to be our bones, which are also going to need transforms. And we'll kind of like ad hoc it for the moment, I think. I think I want to try to get this to work without having the end joint, but maybe we do the end joint just because it'll be easier. So let's do transform from, I don't know. This is going to be 2D, I think, to start off with. So let's do something like 2, 3. Right? And this is bones. We don't really need labels for the bones. We could label them. We could put some names in here too. Why is this yelling at me? Name new. Inverse kinematics, transform default, children, tuple in the children. Let me cargo run. Example, well, I guess these are bins. I should set them up like Bevy does. Inverse kinematics, FABRIK 2D, and this will just run. I guess we can look at the errors in fix first, fix last. Trait bound issues are not what I'm looking for. Expected 1 argument, found 5. God, the view of errors inside of VS Code is so useless. Didn't I just save this? Oh, I did this wrong. That makes sense. That's why I'm seeing that other error. Expected comma. There is a comma. Oh, there we go. I missed there we go. It's the first time in years that I've missed one of those. Okay, so we've got the IK root. We've got a bone. We need another bone. I'm going to name this something so that we can kind of keep track of these if we need to log them out. That's the IK root. This is bone 1. Children. and then basically the same thing, but with a different name. And we'll change this to be like, I don't know, 1 or something. I don't know. Name new instead of name new. Thank you. Should have read chat. You finally got Helix displaying errors, and it's actually quite good. You also like Rust Rover for errors, but lately it's been giving you false negatives. Ooh. False negatives, it's not great. I always use the CLI. Honestly, I think the only thing I use the in-editor errors for is the red squiggles to tell me if something is wrong. If there's no red squiggles, then I'm good. And if there are red squiggles, I go and read the CLI. Unless it's like a red squiggle that I like already know how to fix. A lot of the red squiggles end up being like, oh, I needed a shared reference here and I forgot to type one, or like something like that. So those are really easy fixes without even needing to read the errors. At least in this point in my Rust career. But if it's something a little bit more complicated, if I messed up syntax like this and I need to figure it out, I'm almost always looking at the CLI. Okay, so we've got bone 1, we've got bone 2. I think that we query I don't know, IK bodies, query for, I guess we need the transform, right? And we need the with inverse kinematics. And then we need children query. In this case, we're not really going to qualify the children at all. They're going to be unqualified children. As all children are. Query for children. And then what else do we need? We can iter descendants now from the IK, which is really what we need. We can iter descendants to find the kind of like end joint. And we can I guess in this case, we're going to have the 3 joints that we need. So the transform of the root, the transform of the middle, the transform of the end are going to be our like 3 points. The end will be the end effector. We need a target to get spawned in as well. But the target, I think, will just be the mouse. Zed has been my big favorite lately. Nice. Yeah. Zed is interesting. The GPUI stuff is really interesting too. I just find that it was a little bit less customizable than I needed for stream and for videos and stuff. Let's also get name here, I guess. I don't know. So we've got a body. We will need a target. I think the target is going to be the mouse. But we'll figure that out in a little bit. This should run now. So we don't do anything. We aren't even spawning a camera. We aren't spawning any meshes or anything either. So maybe we should, especially for stream, since, you know, it can be difficult to follow if I'm just thinking in my head. So we'll get a camera 2D. Won't you need a bone length component on each child at a minimum? Will I need a bone length component on each child is an interesting question. I don't think so. Maybe I will. Because these transforms, I'm kind of intuiting as the bone length. That obviously will present kind of a problem, I guess. when we get into the actual algorithm. So maybe we do something like I don't want to do on add here. Trying to figure out how to go through all these bones and like collect the lengths programmatically, because we're going to have to do it programmatically if we do this from Blender. So maybe I'll hard code it for now and we'll go back and deal with it later. Bone length. I think we need a vector here, right? So in this case, it's going to be a vec2. And this is going to be like the next bone's position. Right? Do we not have the swizzles in here? Oh, the translation. I'm just making them both transforms because I want to make it a little bit more clear that this is the same thing. It definitely doesn't have to be. You thought length would be a float? Aren't we going to get a vector? Oh, I guess bone length. You're right. In that case, I think since Z is always zeroed out, we can just do distance. Right, bone length, vec3, distance, next one. I could set these up ahead of time. Maybe I should do that instead. Let bone one distant, or let bone one position, right? And then we do root position. And then we can do bone two position. I think bone two, and this isn't bone two position. This is joint one position, right? Because if we're going to store the distance separately, then this is a joint, not a bone. And then this is this. Root. This is going to be root.clone because we're about to use it. And then this is root translation.distance joint one position dot translation. Right, I didn't call this that. I called this position. So we've got IK root, inverse kinematics, root position, bone length. Bone length is going to be the distance from the root to the joint one. And then the next one's going to be joint one to joint two. So I don't know. It feels a little bit weird because we're iterating over joints, but we're including bone lengths. Maybe that's okay though. So children, And this is joint 1 position and joint 2 position. And these will have clone issues. I think. Maybe not. Pretty sure we will. Pretty sure this is going to be a clone issue. I guess I'm wrong. Why is this not a clone issue? Root position. Do we need clone here? We need clone here, right? I guess we use the translation, so we copy those values because vec3s are copy. So this never actually is an issue. I would have thought that we needed it here, but I guess transforms aren't copy, right? No, transforms are clone. Feels weird to me. Feels weird to me that we then use this and then still have access to it for some reason. Not going to worry about it, but just looks a little weird to me. You thought transform was copy? I don't think it is. Oh, yeah, it is. Okay, transform is copy. I don't know why I was looking down here at reflect and not at the derive, but yeah, it is copy. Okay, that makes more sense. I don't know why I didn't think transform was copy, because most other components I don't put copy on. I think that's why. Okay. You were going to be really surprised if it wasn't copy. Yeah, I mean, it is just like, what, the translation and the quaternion and the scale. So it's like a bunch of F32s, which makes sense to be copy. But, okay, so update. I guess we can do IK bodies.single for the moment, but I don't want to. See, 4 IK bodies. We probably need the entity here, now that I think about it, actually. Because if we're going to entity, we need the entity because not everything is going to have a bone length. These are not bones, these are joints. Since I've moved the entity. So this is going to be option bone length, right? I never use options in my systems, but and then here we'll just IK root. Let's see. We'll just say and we'll just info these. The message of IK root. And this is because I didn't derive debug. Can't debug something if you don't derive the bug. Okay, so this is running 1,000,000 times a second. And we're getting the root entity, the transform of that root entity, and the bone length. In this case, bone length 3.6, whatever. So now we get into what do we actually do? And I think for each of these, we probably want to gather the bones first. which I think we can do just by iterating. I think we can just iterate descendants, right? We do need to find the last one, though. We want to be able to iterate from both sides. So let's do a end effector equals children.iter descendants. No, not IK bodies, right? It's a little awkward because this is like querying for. We could do 2 finds and then reuse this query, but I don't think I want to. Let's do end effectors as a separate query. Which I think we can do. End effector will be the one without bone length, right? Yes, it will be the one without bone length. Query entity transform without bone length. This is not good enough, actually. I'm trying to think about this in terms of what we're going to end up getting later. So what we end up getting from the GLTF is actually from just transforms. Like we only get transforms. They're not labeled. They're not, there's no extra information. So it's a little bit awkward here to try to have a second query. So I think we need to stuff this all together because we can't just search for entity and transform because that will be kind of weird, I guess. Because that just is everything, right? Entity transform is everything. So maybe we stick this in as an option. Inverse kinematics. And we end up with something like let roots equals IK bodies dot iter dot filter. And then this is like underscore sum. Can we match on that in here? I don't think so. I think IK, when we do IK dot is sum. And I messed up my parentheses, which is wonderful. Yada yada, query for all of this stuff. This needs to be a shared reference. Still have transform bone length, IK. And we'll comment this out for a second. Hey, Launch, how's it going? Good morning. Hey, Sylvan. Typist. Yeah. Typist is great. I love Typist. Typist is the bee's knees. I think we need a type signature here. And then for here, we can now iter over roots. So in this case, this is not IK bodies, really. This is This is a really awkward query for like all of the IK joints, is what this is. I have to say that this is going to be pretty dependent later on the GLTF. So I want to make it generic now, but I don't want to oversolve either. So maybe we do put something to make it easier, because this is just going to be a demo, right? And we don't need to solve for that yet. So we could jam those together. But what I think I'm actually going to do is stick an end effector here. So bone length defines it as having a bone. End effector defines that as being the end. Would relationships be too much here? I don't think relationships would be too much here. The only problem with that is we already have a relationship, right? The relationship here is that every child is the next bone. So we could rely on that. I think where I'm tripping myself up here is trying to think too far ahead and think about the output we're going to get from a GLTF later, which is just going to be transforms for the bones. I don't think there's any other information. So we would have to use child of, but I don't know that that's actually enough. Right? Like children and child of is already a relationship. It's just a relationship that's also used for other things. So root children, children would give us all of the stuff. And that is already a relationship, which is exactly what we need. We unfortunately can't query for relationships here, right? So we could instead query for the end effectors, but I think really what we're going to end up having is the ability to like label our armature in Blender. And if we label the armature and then query down from that armature through the bones, I think that's going to work out the best. But I am definitely like solving ahead here, and I think maybe just making it simpler, because this isn't going to, this particular demo is going to be 2D, and it's not going to use it's not going to use GLTF. So I think that we are safe with this approach. It might not be the best. Bone length without inverse kinematics. The other thing we could do, there's other solves for this too, right? If we have an armature, we export it from Blender, and we want to treat a specific subchain of bones as inverse kinematic handled, we can do like an insert recursive with an inverse kinematic component. So there's a lot of solutions here, and I shouldn't be solving that far ahead yet. Hi, what about just using the number of bones in the IK as a member of the inverse kinematics component and just going up the hierarchy this number of times from the IK bone? You mean from the end effector? Or from the, I assume you mean from the end effector. We can go end effector to root. The problem is I want to get rid of the end effector. At some point, I want this end effector to like get deleted because I don't want to have to specify it. But maybe I just have to specify it. That's fine. If we do armatures in Blender with Skeen, we can label all of these. So we could put an end effector on the end. We can put an IK on the root. We can do all of these things. It's not going to be a problem. I'm solving too far ahead. So with that in mind, this can just be a query for, I think, all of the other stuff. We need to know the last one. The last one doesn't have the end effector on it. I think that's fine. If we just do a query for the option bone length that we had, then we get all the bones minus the end effector. And then we can access just the one child and assume there's one child. That doesn't feel good either, though. Deleting the end effector was your idea for this. Cool. I don't think we're at the delete end effector point yet. I think I want to get the implementation working, and then we're going to go back and kind of like remove some things. You thought the IK bone was at the end, line with Blender IK constraint. We can go over that when we get to Blender. We're not doing GLTF just yet, so I've already like stonewalled myself thinking too far ahead. And I'm just going to, I think, continue with what I have. So this is IK roots. We don't need this anymore. Right, we've got IK roots here. We need to find the end effector, which we can now iter descendants. Entity dot find. I want to use entity here, but I also don't. Let's name this something else. Find entity, and then this is end effectors dot get entity. Is some. What is wrong with my is some? Is okay. This is a result. One of the things that trips me up all the time is not knowing whether one of these functions returns an option or a result. I kind of wish we had more consistency so that I could always be like, oh, it's basically always a result or basically always an option, but it is what it is. So I'm going to unwrap this for now, I think, because if this doesn't right. FYI, in case it might help, in Blender, the bone with the IK constraint is the leaf in the hierarchy and contains an IK length in bone numbers, which says how many of the parents are parts of the IK chain. Cool. Maybe we do that. Maybe we don't. I think it would be very cool to get later on to get into kind of like, can we actually use IK constraints in Blender and do those export through the GLTF? And can we use that information? That would be very cool. The way that I'm thinking about approaching it to start with is just throw some bones in the scene and then use those bones. The way you code, you let the auto suggestions write basically every function method, so you're always aware which it is because it doesn't suggest the right one. Interesting. I think my autocomplete, I think VS Code's autocomplete is not great. So I'm never confident, I think, in those autocompletes being correct. Yeah, it doesn't suggest the wrong one. Yeah, I know what you mean. In this case, it did work, but it's not VS Code, it's Rust Analyzer. Yeah, to some extent. The LSP does provide them, but you have no idea how many options I have turned off for VS Code so that it doesn't suggest things that aren't relevant. Like I have a bunch of things because it'll just suggest arbitrary text. VS Code will, if you have it by default. But it's possible I have it misconfigured too. I'm not against that either. So we have the end effector entity. We have the root entity. We have the bone chain. And now really what we need is, I think IK bones with respect to error versus result, you suppose it's the difference of whether or not getting T is explicitly an error or not? Yeah, I mean, like, it uses the right thing. Well, what is the error for get? This is a query.get, right? So query, and then we get, and get could have a query entity error, whatever a query entity error is. I've quite honestly never required using a query entity error. Query does not match. Entity does not exist. Alias mutability. So I guess if I pass in an entity that got deleted, I would get an error. Or if yeah, I'm always like querying and then querying over all the things that it should have. So I guess it would have to, like, at runtime have a component removed that like in between when I queried for it, and which would be really weird. Yeah, I have to say that I just don't run into these errors really ever. But they are errors, and they are separated, which is cool. Also, you're convinced all autocompletes got worse with AI. I'm pretty sure, yeah. If the LSP did not provide any suggestions, yes, but if the LSP is just taking a second, it doesn't show anything for you. Yeah, I mean, I've been running a stripped down VS Code for a long time now, right? It's not a recent thing. It's not like I tested the current version and was like, oh, I can reset my settings now. So it might have been worse and gotten better. That's totally a possibility. Okay, so we've got root, IKs, end effectors. We have nothing visual here. We might want something visual. Gizmos. The question is, do we do gizmos inside of this iteration? Or do we do like a mesh 2D? Like an elongated ellipse? You mean the only thing you did was disable all AI features or whatever it's called, and autocomplete has only improved since you started learning Rust? Yeah, I only recently found the disable all AI features button. I already had the extension for what Copilot or whatever they force on you disabled, but I didn't have like the other option. So it like occasionally would just open the Copilot menu when I started a new VS Code, which was super annoying because I literally never want that. If there's an LSP and it has suggestions, those should be the only options. That hasn't been my previous experience with VS Code, but I believe that that's yours. You would use gizmos with 3 axes, X in red, Y in green, Z in blue. We're using 2D right now. But we could do axes 2D. Oh, we can just pass the transform in, which is cool. I don't think this will... I don't think this will give us the right stuff, but maybe it will. So let's get gizmos here. So we haven't iterated over everything yet, but let's throw an axis on the roots at least. Sick. That is the smallest root ever. I forgot how small 2D was. Maybe we need to make these quite a bit bigger. Let's make these, I don't know, something more like 200, 300. Assuming the axis will scale up with it. It does not. Transform point, base length. Where is our... This is like 200, 300. Let's make the base length 100. We're just scaling everything up for no real reason. Okay, so this is our transform for the root. And then I guess if we're really going to do stuff, we can actually do something else, like debug transforms. Query for transform. For transforming query gizmos. And then we just throw this in update. And maybe we can bring this down to like 30. And get rid of this one. And here's the gizmos for each of the bone positions currently. And theoretically, we could make these smaller too. But yeah. You feel like you also want an arrow that is bone length long and pointing at child eventually? We could do that too, I think. Arrow, start, end, color. Do we not have dash? I thought we had dashed here. Maybe that's a global configuration. Ray, rect. Draw a line. Positions color. Positions color. Got to figure out why we do have dash lines. I just never use them. So we will, I guess, draw an arbitrary line for the moment. Let's bring this into scope. Let's do the whole color palette, and let's do resource, clear color, slate 950 for the background. Into and then this little arrow 2D is from 0 to X, which is not really what we want. Let's do, after we've found the effector, maybe we find the transform and draw the line. Just for kicks for the moment. Gizmo config, not global, but grouped. Yes. Config. Oh, it's not config. Okay, cool. This is just transform. So let's do gizmos here. Gizmos dot config dot line dot style equals gizmo line style dashed dotted. Maybe dotted is a little bit easier to start with. Which is behind a shared reference, not a sign. Is that because Gizmos only gives it to us as a shared reference? I guess, yeah, it is only a shared reference, isn't it? So we've got to kind of like globally configure this. Yeah, Gizmos is a system parameter. I was just checking to see if there was some magic. I think we have to insert this at the beginning. Feels weird that it's not like her line setting. Gizmo config. This inserts a custom. There's got to be asset handles. Gizmo builder. I don't want Gizmo builder. I just want to. Hey, Yuto, how's it going? Doing all right. We're trying to get through some IK here. FABRIK algorithm. I'm letting myself get sidetracked by chat all the time. So I'm looking at gizmos right now. Which is just how it be sometimes. Why can this not be? I mean, I guess we can config a gizmo group, but config store, resmute, gizmo config store. dot line dot style dot dotted. And then we just don't worry about it down here. So all our lines will be dotted, which is fine. Okay, interesting. 2D or 3D. Starting with 2D, hoping to move into 3D by the end of the stream, but you know how it goes. The way you do it is leave the default config untouched, add your own FABRIK config, draw some gizmos using this other config. Yeah, that's totally reasonable. And I think that's probably what I'll do later. I'm just looking for a quick solution right now. Because I want to get back to the actual algorithm. Oh, that's all lines, including the axes are dotted. That's not fun. Maybe we do a custom config for gizmos. Gizmo assets. We don't need gizmo assets. We need gizmo group. So we need to init the gizmo group. Dotted gizmos. It feels weird that we're going to draw an arrow with like a dotted. I guess I don't know what it's going to turn out to be, but we'll see. This is round gizmos. I think that's it, right? And then we just access gizmos and we do this at the beginning instead for dotted gizmos. And then when we access gizmos down here, we want to grab both of them. So here we can do dotted gizmos, and then this should have lines for the axes. Method not found. Okay, what did I do wrong? Oh, I have to parameterize it. Gotcha. I don't know why I thought that just like became magically a system parameter. Cool, and then we can kind of like specify what we want here for the style. I don't like dotted, so we're gonna go with dashed. Gap scale, let's call it like 5. Line scale 10. I don't know what parameter that is actually. Cool. So we have like this color now, which I need to change from green because I don't want it to be green everywhere. Green 400, right? Arrow 2D 0. This is just pointing like east. So let's do dot with alpha 0.4 maybe, and let's name this like, what's a good color to use for this? Magenta. Do we have magenta? Yes, we don't have magenta. Do we have pink? We have pink. There's going to be a pink arrow because I'm trying to leave red, green, and blue for the axes. So we'll have pink here pointing to our locations. Cool. So we don't have the locations just yet. This, then IK bones. We now have the root and the end effector and our gizmos set up. Chat disconnected. Cool. derive gizmo config group. So we have the root entity, we have the end effector. These are both the like start and end root positions. We now need to figure out what the angle is for that joint. To do so, we need to iterate down the, I guess from the end effector back up, right? Here's our fabric. I wish I didn't have to look at this sidebar. There we go. So we have fabric. Fabric is, we have our joint positions. We have all the math that we need to calculate. I guess the first thing that we do is if end effector is out of reach, then I don't know, just log something in return. So end effector, we basically just need a query for all transforms. I guess we can do that here. Right, we don't actually need this to be end effector. This can be like transform end effector, right? And now this collides for what reason? Oh, because this would need to be with, not a collision, just a type mismatch. So we iterate over, we probably want this to be find map if we're going to do it this way. Not particularly effective if you need to mutate. Why is get different? Why did that change the property of get that we needed to send in? That's weird, right? I guess find map and find are different, so that's fine. So we have the end effector. The end effector is actually just the transform. So let's call this root transform so we don't get confused here. And we'll call this like root bone length. And then root bone length. We have to get all the bone lengths going backwards, right? So let total length, which is something that we could probably keep on the root as a setting, but we'll calculate it here. Total length is end effectors. We also need like parents then. Any parent with a bone length up to inverse kinematics. So I think we can't early terminate a fold. So I think I'll just use the for loop. Right, total length will start at 0. Not that total length being 0 is a great option, but for ancestor in parents dot iter ancestors end effector, I guess dot one we're going to need here, right? Why is bone length a component / needed? Because I think I'm going to mutate the transforms here in a second. Is really what it is. So keeping the length of the bone around makes it a little bit easier to not have to worry about that. Because the algorithm that we're using wants to change the positions of these bones. And it's easier to just know that length rather than have to try to recalculate it and make sure that we don't change it. But I can also go back later and be like, oh, these are the lengths that are supposed to be there. Total length should probably start as root bone length .0. We're going up from the end effector. So it's 0 from end effector. We could go the other way. We could go from root down. And just assume that everything below. But I think we have to go up instead anyway, right? I think our algorithm requires that we go up at some point. Right, the algorithm is given all the joint positions. I guess doing the total length is, yeah, it's P1 minus T. And then we reset that to I guess we do let initial root equals right, the root entity. I guess we do start at the root, don't we? I guess I was thinking about the backward pass. So we start at the root and we move the end effector to T, which after all of this happens, it could be off again. So we do actually start from the root. You're right. So let's do that. That's actually even easier. But we do need all of the bone lengths. And I don't have a query for all the bone lengths. This is going to be just hilarious until I need to update something, but we're just going to go with bone lengths. And then we can go, what is it? Root, and no, not root entity. It's children dot iter descendants root entity dot fold, or I guess reduce, right? Because if we're going to start with, actually, we need to do fold because we need to get the other entities, right? We need to get the bone lengths. So I guess we map entity dot get entity. I guess we filter map because we're going to basically skip out on that last end effector, which won't match this. So we have our iter descendants root entity filter map. We're using the child or the children. Let's say use child of relationship to iter bones. which means that we should have all the bone lengths at this point, which we can then reduce. Right, these are both bone length now. The only problem with using reduce is that then that locks us into that type. So let's start with 0. And this will just be, is this a tuple? Oh no, it's sorry. It's the accumulator and next, right? It doesn't matter if that's mutable or not because we're working with floats, so it doesn't matter. And then it's accumulator plus next dot 0 because we didn't implement deref. So this should end up with total length. IK chains need an end effector joint. We don't really need this right now, so I'm going to just ignore that for the moment. Total length 223. That doesn't sound right. Absolute value. You could map in some. If I didn't have a new type around it, or if I implemented add for it, yes. The lengths are useless, except if all bones start where the parent end. Except if all bones start where the parent end. In your opinion, a bind pose is needed, but it would just be another transform. Yeah, we're keeping things simple to start with. We're doing 2D, we're doing just like storing things in components. We're going to work our way up to like a real actual generic IK solver here. This bone length looks wrong. This is the case where right bone length is needed as the fold initializer. Map to next.0 sum. You're not wrong. You're not wrong. And this gives us the same wrong answer, right? Yeah, 223. Are you allowed to share your project? You don't want to be rude or derail the session. I mean, if it's Rust or Bevy related, sure. You're not going to be able to paste a link, so you're going to have to talk about it kind of abstractly. That's a YouTube restriction. If it's anything, Bitcoin related or anything like that, no. But if it's like Rust, Bevy related, that kind of thing, feel free. So instead of fold 0, it's fold root bone length at 0, but we should be getting the root bone length, right? I guess this doesn't include, does it? I think you're right. So then we end up with 584, and we have bone length of 360, and I think a bone length of 220, whatever it was. So that looks right. I think that's the total length. The same wrong answer. Hey, it's better than a different wrong answer. Well, sometimes. Depends on the context. Thanks for calling that out, Synth. You were right. There's probably a better way to write this, but, you know, I'll clean it up later. So we've got our total length. 223 plus 360 equals 580. Yeah, but wasn't there leftovers? Leftovers is so the wrong word for that. Yeah, 223.6 and 360.5. So we get the extra one. Yeah, 584. 584.1 is correct. Okay. We made it to step 1 of the algorithm, y'all. So, the target position, we don't have a target position. We should grab the mouse position, which I always forget how to do, if I'm being perfectly honest. We just did mouse position, didn't we? Maybe we didn't. This is one of those things I actually always have to look up. Because I think we get like accumulated mouse input and stuff that are easy to get, but for some reason, like current mouse position is not. I guess we could click, but I really want it to be active. Like those are just mouse clicks. This is clicked with no position. What is cursor options? Visible grab mode? Nope. It's like 40,000 lines, docs test examples. You hope to share it here because you are the exact target who would love to create to embed music sound generation in Bevy projects. I feel like I've seen that before. Use a window observer. What's a window observer? What window observer? Attach an observer to the window element? Woo! That is some 200 IQ observer action there. That would, honestly, that would have never occurred to me for whatever reason. So you want an observer for over, then? I guess not. What are the other? You mean the Bevy cheat book, right? Yeah. Bevy cheat book is growing more out of date as time goes on. I think the last time it was seriously updated was really for like 13, 14-ish. It's still got some good information, but yeah. If I look for cursor position, I guess that is right here, isn't it? The cursor position in this window in logical pixels. So we would have to take that and transform it into the world. Which should be fine, but I think if the observer gives us the actual position in the world, that would be cool. Change Encoders is a new cheat book, you feel? Yeah, we'll see if they keep it up to date. It doesn't feel... How do I frame this without... It seems great, but it is very much like a very ad hoc document. Whereas the cheat book felt like it was a much more targeted resource. right? The unofficial Bevy cheat book has a cookbook and has a bunch of like setup tips and other things and whatnot. How to work with 2D and 3D cameras, how to do a bunch of other stuff. I guess maybe they're the same. I feel like the cheat book is just more comprehensive. But in general, I envision the same fate for tainted coders over the long term. Because I've spent a lot of time thinking about this, thinking about how to sustainably build this much content and update it. And the answer is not do it ad hoc when you have time for each update, is the way that I'll put it. But I'm glad people are getting value out of it. Absolutely. Okay, so cursor position gives us the logical position in pixels. We would have to use to world or whatever the function is called that I can never remember. Viewport to world 2D, right? Camera transform, viewport position. Yeah, so if we do window cursor, oh, that's the example they're showing right here, actually. What's what I get for not reading the docs. The observer is cool, though. So we need single window, and we need camera. And then here's all of the code for that. And this will get us camera, camera transform, cursor position, world position. We can't let chain let else. You don't understand what you mean by ad hoc. Don't know. All I can say is it's always been updated in relatively quick after a Bevy update since you've known of it. That wasn't true for 0.16. 0.16 got updated right before 0.17 came out. But what I mean is that this was started kind of like this. Like the first line on the site is these were created like as guides for friends, like ad hoc as those people needed them, which is great. Means that they were like realistic, like people who needed specific things were explained like that. But it's not a it's not comprehensive in any way, and it's not ordered in any way. And things like XPBD probably should be taken off at this point. But I don't want to sound like I'm harshing on it because like people find it useful, which is great, and that's really all that's necessary. Your lazy solution would be just do that in a system and stick it in a resource. You mean the window position? Or the mouse position? It's not a bad idea. Let ad hoc docs like that just provide a different kind of value. Yeah, I've by no means saying they're valueless. Just to be absolutely clear, the bar we're working with is like these things are valuable to people. That's why we're talking about them. Just to be clear, that's the bottom line bar. Like the cheat book is useful, but it's getting a little bit out of date. Tainted Coders is useful, but maybe it's a little bit ad hoc. Like these are useful resources as the bottom line bar that we're talking about. Just to be like totally clear about that. Yeah, the mouse position in world space, yes. You sent me an example where you implemented a pan cam with window observers in Discord. I'm really curious to see the observers thing. Oh, you just do it when you spawn? Oh, I guess you get the window in the startup. That makes sense. So anytime the mouse moves, theoretically, you could throw that into a resource. That does sound much nicer. Let's do that. Let's see. World to viewport. You're still using world to viewport. Yeah. Let's just drop this like way down here. FN update mouse position. And then you're going for the camera. We need to query for the camera because we're in a different system. I guess why am I doing it like this? I don't know why I'm doing it like this. I'm split brained right now. Feel free to copy it. It's pretty compact. Cool. Appreciate it. Having different forms of documentation is awesome. Yes. And actually, the more people, like if we had 5 more of those kinds of sites, that would be even better. Right? Like a bunch of people focusing on maybe the things that they care about on each site would be fantastic. And that will always be true. It's one of the things that I say whenever people are like, oh, I want to make videos, but like, or write content or blogs or whatever, but people have already covered the topics that I want to write about. Like, yes, somebody has to have done it before for you to have learned it. Not everything that you write needs to be like brand new PhD breakthrough research, right? Things can be written in different voices by different people, and they're all useful on the exact same topic. So you're doing an observer. You're doing I don't know, I'm going to call this observe mouse. And you're saying drag for trigger pointer drag. And camera query with the global transform single. You're doing a pan cam, so you're doing mutable. We're not, so we'll do single. We only need global transform, right? I guess you're going world to viewport here. Camera world to viewport gives you, what does world to viewport give you? To viewport. Given a position in world space, use the camera to compute the viewport space coordinates. Okay. I don't think we need the camera at all. I don't know why I was thinking about the camera. And camera query, window cursor position. Oh, we do need the camera position and the cursor position, right? Sorry, I'm looking at multiple different examples and compiling them together, and I'm making myself cross-brained at the moment. This is old because it uses trigger. And this is camera and camera transform. In this example, was camera transform global? Yes. Yeah, viewport to world is, well, viewport to world is just a thing on the camera. So yeah, I guess we'll call this camera query. Why not? Differentiation overshadowing. So observe mouse on pointer drag on the window, which you set up in window. So this is window, what single entity with primary window. And then commands dot entity window dot add observer observe observe mouse. And then this is not going to be that because this is going to be dereferenced. And then this should run. Thus, we should be able to hear. You're using, I see you typing. You don't use drag.delta. You don't use the actual drag thing, do you? Yeah, I mean, I was hoping to use the drag event, right? Like you were saying. But the delta and the distance don't help us. We still have to calculate that anyway, right? You're using drag. Maybe we just want over. Position as a vec3. Position data may be in any space, world space, screen space, local space, specified by the backend providing it. So over doesn't tell us what space it's in. I wonder what space that's in. I want move, you think? Oh, fires while a pointer is moving over the target. Yeah, that makes more sense. Okay, this is stored in screen pixels, not world coordinates for the delta. That doesn't mean anything for the hit data. So hit data.position is question mark. Window picking is viewport space. I feel like I would hope so, but you know, you never know. Right, that's why. That's why. We're gonna r hash move, I think. So let's info r hash move dot no suggestions because I'm great at writing code. Maybe because of the hash. Does this break if we're gonna call this shmove? What is going on there? Is it because I'm in info? That's so awkward. Okay, dot hit dot position. So we're gonna get the position, shmove hit return, log position. I am going to get rid of our other infos for a second so that this doesn't overwhelm instead of filtering. There is no hit position ever. Is that a bug? Or did I do something really strange? On pointer move. right? Hit position doesn't exist. Does delta exist? Hang on. That feels really weird, right? Yeah, you think that's a bug? I think that's a bug. Hit data, camera 0, depth 0, position none. Did I put this on the wrong entity? Primary window. I mean, these are going to be the same thing, right? Okay, so this is a bug. I'm pretty confident that this is a bug. Okay, so I'm gonna, actually, are you gonna file this? Or should I file this? I'll copy this over for later and I'll file it off stream. If you don't get to it. Yeah, okay, so that's weird. Just, I don't know what to say about that. We do end up with data here. Make this a little bit smaller just so it's easier to read the plethora of output. So we do this. We get pointer location on the event, which is in screen space or viewport space or whatever we want to call this, right? So we're looking for pointer location. It's just not in the hit data for some reason. It's really strange that the hit data doesn't have the information we're looking for. Pointer location is actually what we want. Pointer location dot position. I guess it's not a hit is the logic there. And then we don't need to let else because this is just always going to be there. Right? Right, like it's not a click, therefore it's not a hit. Well, we get pointer position. We do get the information. It's just not in the hit data. So that to me says either this is a migration thing, or because there's no like click, there's no hit, and you're just getting the pointer position. Nope, the code is really simple. Okay. It's just never been implemented. That's really interesting. That's really interesting. I mean, it happens, obviously. Okay, so we have the position. Here's our camera. I swear we'll get to IK at some point. Perfect, thank you. I'll check that later though. I do appreciate you sending me links like that. Let's do window cursor position, which we don't need because we already have the position. So we'll just name this cursor position, I guess. And then we'll be schmovin'. And this will be the resource for the mouse position. And this is a vec2. So this will be like mouse position equals this, right? Something like that. And this will be mute mouse position, res mute mouse position. Mouse position is going to be, I guess I'll just stick it right here because this is really the place that it's like defined and used. This is a resource, not a component. I'm just typing component out of habit. Resource. I'm from Jersey. Mouse position, vec2. That seems weird. What did I do wrong? Can't be dereferenced. Oh, right, because I type out the whole thing instead of the shortcut. And then this can't be dereferenced because it doesn't need to be. This goes up through the hierarchy. So this will crash because we haven't inserted that resource, but we can insert the resource. I guess in this case, mouse position can be like an option res mouse position. And then this is like let sum mouse position equals mouse position else return. And then this is option res mute, which would mean this is not res mute currently, mute. This comes in as res mute. Otherwise, commands.insert resource, mouse position, world position. And we need commands. So in this case, our stuff won't run unless we move the mouse over the scene, which I think is something I'm okay with for the moment. And let's do a gizmo. I guess this doesn't need to be mute, does it? We don't need the window. And then we can update mouse position. Where's our line being drawn here? Here's our first line ever. And we are going to do root entity transform to mouse position. And this is problematic because it could let in a draft. Arguments to this method are incorrect. The nice thing about having a type system. So we're a little bit delayed here behind the cursor, which I don't really care all that much about. It catches up. But this is our cursor position, which is great. So since we have the cursor position, we probably don't need to write this. Picking the window on the camera when clicking is part of the viewport without anything would be weird. Picking the window or the camera when clicking in part of the viewport without anything would be weird. Yeah, making a click. You kind of wish the 2D camera always had the mouse position on the viewport available. Yeah, don't we always have that around? That's like a thing that just exists, right? That's not a thing that we really need to... I guess the only reason that I can think of against that is maybe... No, like maybe there's a way in which we don't send the events or don't accumulate the events if you're not using them. That's the only reason I could think of for not having that data readily available. I guess like I don't really mind the current situation where we have to do like viewport to world 2D. Let's see, multi-window, cursor on camera. What happens if you do multi-camera? I guess if you do multi-camera, then each one like your cursor could jump from one position to another as it crosses over the boundary. Not multi-camera as in like one stacked on top of each other, but multi-cam as in split view, like split screen, multiplayer. I guess if they're stacked on top of each other, that could also be different, right? There's nothing to say that you're... Maybe. Your point is that the camera itself has the coordinates as an option? Yeah. It has the mouse coordinates? I guess you don't need it for all cameras, right? Would be the thing. So if you had 300, 500 cameras because you were doing a bunch of icons, then you would be calculating the mouse position for 300 to 500 cameras, even though you don't actually need it. Not that people are really using 300 to 500, but I think multicam is actually a potential Bevy strength. And I would like it to be easier to use multicam, not harder. But it is just like, I don't know, a matrix multiplication. So like maybe it's not really an issue. In any case, we have the value now. So we have our root, we have our bones, we have all of my various meandering attempts to do things. We've got the total length. And we need to check for a target. The target is the mouse. So if total length is less than mouse position dot, or I guess .0 dot length. I guess this isn't really a warning per se, right? Because this is going to happen all the time. So if we go, mouse is out of reach. Feels awkward. Feels like something weird is happening here. Shouldn't that be firing a lot more? Okay. I guess we just have like a really big circle. Maybe we draw a circle for the reach with a gizmo. Let's do gizmos dot circle 2D. So if we do a circle 2D, this is the isometry. The isometry can just be the translation, right? In this case, having the identity is fine because we're at the root, but really this should be the position of the root bone. The solution is case dependent. Oh, I think I missed a couple messages. But what if you have an extra camera viewport for something like a map and you don't want to use this viewport camera to project onto the world? Then you simply don't access the cursor position from that camera. Yeah, I mean, it would be nice. It would be nice to have a more interesting solve there, right? Viewport to world 2D is not really an intuitive thing to reach for, especially for a beginner. And I feel like getting the mouse coordinates on the screen in world space or something like that is a pretty common ask. But I can definitely see the argument for not like automatically doing that calculation. Because also viewport to world 2D can do arbitrary versions of this, right? It doesn't need to be a camera and a cursor. I don't know. I still think my primary concern would be the let's not do red. Let's do, what other colors do we have? Slate 50, slate 500, just slate 400. And then the isometry, or like the radius, is going to be the total length. And this should give us like the circle in which we are supposed to be operating, which is most of the screen right now. And I would like it to actually be smaller, I think. So let's make the bone length a little bit smaller, and this should automatically adjust. Yeah. Because then we get stuff that is like clearly out of bounds and clearly inbounds. Not arguing for removing it. Yeah, render target is not always viewport, can be a texture, lots of moving pieces. I do agree with. And I do agree that it could be better. I just don't know what the real solution is. Okay, so warn, mouse out of reach. Doesn't really matter. We'll just return if mouse is out of reach. Which brings us to, are we in our loop yet? This is the loop algorithm, right? So we actually do have a loop here to calculate total length. Okay, if target is reachable, right? Total length. If target isn't reachable, return. I'll add some comments and stuff here. Set B equals P1 as the initial root position. So this is our root, right? This is our initial, in this case, root. They have a stateful algorithm here. So I do think that we are going to have to do this like out of the loop. I guess maybe we bootstrap this into it. We'll see. So let's follow this for now. I don't want to call this root position. What do I call this? This is the current root. And this is root transform translation at the moment. And we'll work with the vec2 here. And then we'll evolve it to vec3 later. Find the distance of the end effector from the target. So we need to find the end effector. Here. I guess we could do this outside of the loop too. I think this panicked last time we had it enabled, so we need to debug that. IK chains need an end effector joint. End effector is children, iter descendants, current root position. I guess we can start at if we're doing it down here, but otherwise it's root entity. Find map entity, end effectors get entity, okay. So we're looking for the first one that has an end effector, which is this end effector component, which should be on this, which should be a child. Not a direct child, but a deep child. So the question I have is, what are we getting here? Inspect is really cool because this will put us through all of those children. In this case, it's 16, 17, 18, 19. Like I don't know what those components necessarily are or what those entities actually are. So we could do like commands.entity, entity.log components. Oh, we don't have commands here. So this will give us the entity followed by all the components that are on that entity. And it should crash as soon as it tries to do this. So we'll get one iteration of it by default. So entity 16 is got a bone length. This is just a name and a child of. Did I mistype? You know what? You know what I might have done? I know what I did. I made the same mistake everybody makes. Actually, literally the first time I've made that mistake, if I'm being honest. Which is really funny, actually. The issue here being, if you pass in a tuple, that is all the components for one entity. If you pass in 3 separate things, that is 3 separate entities. Okay, so we have the end effector transform. And we are looking for, I'm going to get rid of this inspect because we don't need it anymore. This is if target reachable, set the root position, find the distance of the end effector from the target. So the current target is the current root position. Total length is not what I wanted. Current root position. They do it this order, so I'm going to do it this order. The end effector minus the current root position. This is gotta be a dot translation xy, which I might want to do directly up here because we don't really need any other piece of the translation ever. Okay, while diff is greater than tolerance, perform forward and backward pass. So we need a tolerance. What is our tolerance going to be? We'll start with F32 epsilon, I guess, and adjust as necessary. This could also go into a resource, and we could use the resource to set the options, which would make it interesting from an interactivity perspective, because you could set the tolerance to whatever you wanted. So this assumes some things which are not necessarily true. If tolerance greater than tolerance, or I guess while, right? If distance is less than tolerance, right? Diff less than tolerance, return. Otherwise, continue. While diff is greater than tolerance is just like, I don't know. It feels like a really weird way to frame that, but maybe I could just translate that into a while loop, since it does need to be a loop. But this doesn't change unless we change it. So we have to do the forward and backward pass. And I'm not exactly sure where the state that they want us to maintain needs to go. So I'm just going to keep doing this. You could always rewrite it. So this is forward, backward pass. End effector from target, diff greater than perform task. So this is the pass. We are in pass. We're going to have to do multiple of these passes at the end of this. So move the end effector to T, where T is the total. Where's T? The target position. Target position is the mouse. So move the end effector to the mouse. The question here is, I've accessed transform in a shared way in a couple of places. We are going to need mutable versions of the transform for all of these entities. Up until this point, we're using IK roots, root transform here. I think we're going to end up with a query collision because I want to write mute transform here. I think this is going to be a runtime breakage. or maybe compile time, I forget. So this is accesses component transform in a way that conflicts with previous system parameter, considered being disjoint or whatever, but we actually don't want to be disjoint. We actually do want all of these things. So I think what we can do here is get rid of them. And only use this. And then root transform is always going to exist, right? How many root transforms do we use? Just the one for now. So this is going to be transforms.get root entity unwrap, because this has to exist. And then this is going to be end effectors. Find map entity is what we're doing right now, but we really just want to find at this point. I guess we could find map and then map over it again, but this is the children query. So the children query should give us the entity, right? End effector entity. And then let end effector transform. Effector entity. All right, this has to exist. This has to work. So we'll unwrap and then end effector. I guess that's just what I called it. So we'll just call this end effector for now. And then we're going to need to mutate those things. So we're going to do get mutes later. So doing it this way uses like the transforms as kind of like a database where we can just kind of reach into that query for the transform that we need, when we need it, how we need it. And that lets us get mutable access to the transforms for everything without tying it up in a bunch of different queries. Because we actually do need to overlap these these mutable transform accesses if we query for them mutably. So we are at a point where we need to distance, forward, backward, pass, move the end effector to T. So we're going to do transforms.getMute end effector entity, right? And I can just kind of like do this. So let mute transform equals this. Transform.x equals mouse position dot x. Transform.y equals mouse position dot y. Translation. And this is .0 because I didn't implement dref. I should implement dref. So we'll just kind of block this out and label this as move the end effector to T. At which point, for each of the previous points, pi, I equals n minus 1 to 1. So we're going up the chain, right? Backwards from our target. So this is going to be a for transform in children dot iter ancestors end effector or for entity, I guess. Transforms dot. Do we window this? Hang on. We need for each of the previous points, find the vector and the new position as relative position of that joint along this vector. Relative position of that joint along this vector. So we have the distance and we need to just use that direction. So it's the vector from, if I remember correctly, it's the vector from where the joint currently is to the new position for the previous. So we do need to windows this because we need to access that vector. Unfortunately, I think iter ancestors, as we just recently discovered with iter descendants, will not give us the root. So I feel like that's awkward for us. Maybe we can chain this in, do an iterator chain the entity for the end effector onto the end. Is setting the end effector position like that okay? What about the parent transform? Shouldn't we convert the mouse position from global to local somehow? Yes. Yes. I'm working on the loop logic in my head right now, so I just haven't gotten there yet. But you're right, because transform is local, not global. So I guess the question is, how do we set the child to a global position? Which I think there's a function for. Can't remember the name of it. It's not going to be on transform, I don't think. Maybe it's some magic of the algorithm. You mean... No, I think these are global positions in the algorithm. The best we would get out of the algorithm is, I think, relative to the root bone or the root joint. But that's not what this is currently. We do actually need to set the global position, and you are correct about that. I just need to remember how to do that, ignoring the parents. Those methods are approaching OOP. I, base, iter, many, unique, mute. What do you mean? Like you just don't like long names, or like what's the correlation to OOP? Yeah, it's also not OOP. But I mean, yeah, I'm not going to get into a definition battle of what OOP is and is not. I'm more interested in why you don't like that, or like what function you thought was particularly like that. There is a function for this, and I never remember the name of it because I never use it. From isometry, from rotation. It's not on transform. I almost certainly not on transform. But I can't for the life of me ever remember the name of this function. Children, spawner. Is it spawn? Is it one of the insert children things? Add one related, add related, archetype as mutable, as read-only. I guess we could theoretically just store all of them and then iterate once at the end to set them all. I kind of would like to just set it on transform right away. But if we touch the parent, we have to like modify the parent transform without touching the child. I could have sworn there were functions for this somewhere. Insert related contains clone and spawn entity cloner. You would take the global transform of the parent, then invert it. The algorithm is just add all the parents together. So like we could just go up the chain. I really in my heart of hearts feel like there is a function that does this because this is a common need. It's just not a common need for me, so I can never remember the name of this particular function. Back forwards, reparented to. Returns the transform self would have if it was a child of an entity with the parent global transform. Well, that's one of them. I don't think that's what we want. I think the best option for us might be iterate up and keep the state, and then iterate down and set them all. Because otherwise we're going to be kind of like dealing with the like continuous movement of these things. And really what I want to do is set the global position, which I think we're not supposed to do. Because then we have to modify the child too, right? If we set the current position, then the children are already in their positions, and thus it just gets a little bit confusing. So I think for the backwards, what we'll do is just keep a vec of these values. So instead of actually setting the transform here, maybe we do a pass to fill a vec. Can we get the full chain somewhere before this easily? Root entity, etc., iter descendants. This is basically what we need. We need children, iter descendants. In this case, it's filter map, but we can just do it all the way down. So we can do let current positions equals children, iter descendants, root entity. Map to a global transform XY. Right? Entity. Deciding whether I want to filter map or like, I think I want to unwrap here. Right? And the only downside of this is that the root entity doesn't get the same treatment. So really what we need, I think it's really annoying that iter descendants doesn't use the root. Is that just me? Or is there a function I missed? Right? Like I get that most people want to iter inside of like a scene, right? So you don't really want the root in that case. It is strongly advised to use iterator for each if it tangibly improves performance. I feel like we should have iter relationship with root or something, or iter descendants with root. Maybe I'm wrong. Maybe there's a reason that doesn't exist. In this case, we're not going to have vecs that are too big, so I'm not too concerned about it. I just find it, I feel like it should exist. Okay, so let's do yada, yada, yada. Same call here is going to be the first. And this is going to be .x translation .xy, I believe. And this will be current positions equals this. This is no longer entity, so this needs to be root entity. It probably behaved weird if a bone has more than one child. What do you mean? You mean your matrix invert? Oh yeah, if a bone has more than one child, yes. Yes. That is a consideration that I have for the future. That is something in the back of my head that I don't want to deal with right now. That is for when we deal with GLTFs, we are going to have to consider the fact that people put arbitrary stuff all over GLTF files. That is a thing. That is not for right now. For entity in children, iter descendants, dot translation dot xy. current positions dot push. This is mute. Have an error somewhere. Unclosed delimiter. That's why Rust Analyzer isn't helping me out here. This. There we go. Oh, it's like, why would you ever want more than one? Turns out it's the usual problem with software development user input. Yeah. So like, theoretically, the inverse kinematics that we're programming right now works with a single chain, right? But that doesn't mean that the single chain that we want it to work on is the only chain available. For example, if you have an arm with another arm growing out of it, and you're building a monster, and you want one arm to kind of just like be there on the arm, and the other arm to be the one that works, you could IK the first arm, and you would have a second bone splitting off in the middle of a joint. Like, it's not necessarily something that I would do like that, but like, this is not outside the realm of possibility, right? People put things in weird places when they can put them anywhere. So we will have to consider that. You've only done IK in robotics, and that was 20 years ago, but it was much easier than this. Well, part of this problem is I've never done IK before. If I had done IK before literally like today, this would have gone a lot smoother. It's common to do things like that, not a user abuse. Absolutely. Absolutely. I mean, there will be like more egregious examples, but absolutely that is not an issue. Also, people parent things to bones like meshes. So like, this iter descendants algorithm will not work for that. Well, that's not entirely true. We'll just have to modify our queries and stuff, but you get what I mean. Okay, so current positions. Temporarily cache global positions for a mutation. So we need to do our forward backward pass, which means we need to take whatever's at the end of this. Hopefully this is the right order as well. I didn't even check. All right, so we get 0, 0, 100, 200, 200, 300. So we have all three of our joints. What looks like in the correct order, right? 100, 200, 200, 300. That's the correct order. Maybe not a monster second hand growing out of the IK chain, but something like a non-deformed bone to a parent elbow protector or something like that. Yeah. You suppose skeletons are a thing, but would you IK the whole thing or just parts of it? The more IK you do, the more computationally intensive it is. So I think that most people try to limit the amount of IK just for performance reasons, not necessarily for any other reason. There is that game with the tentacle grass that I can't remember the name of, that did very interesting, like, if I remember correctly, effectively GPU powered IK grass and tentacles. But they did like a very specialized pipeline for that. That was not just like, you know, throw IK on everything. There's also like, is your game like a physics game? Then more IK might make more sense. You know, if it's one of those like what is that that walking game where you like are a baby walking up a mountain, or if it's like one of the like QWOP or something like that, you know, where you're moving each individual foot and trying to balance the person's body, etc. Okay, so we have everything in the right spots. We're going in from the back here, and we already have this. So we get to start with now what is current positions dot iter. Do I need to iter back? No. Last mute, that's what I want. Expect bones to have a bone. So this is the position of the end effector, because it's the last one, at which point we need to set X and Y, which we can't, how do I frame this? We can't swizzle it. So I'm going to put it inside of a block so that we just like are guaranteed to drop this immediately. Let mute pause equals this, vec2, pause.x equals these two things. But yeah, the reason this feels, if it feels complicated, the reason it feels complicated is because I get distracted easily and I take a lot of detours. And also, I've never done IK before. So today is the first time that I've ever seen this algorithm, and you're watching me work through it in real time. Okay, so current positions, mutate the last one, and then we have to iter windows. So this is going to be like current positions dot iter mute. We need to like reverse this for Windows. Is there like an R Windows? Double-ended iterator. R fold isn't what I want. I want Windows and then just to get next back. So while next back. Why can you remove the mute from position? Because position in this case is a mutable reference. So this is a mutable reference to a vec2, and we're setting a field inside of that mutable reference so we can go directly through the mutable reference to that value. Whatchamacallit? Binding mutability and reference mutability are not exactly the same thing. Sometimes they line up like you're asking about, and sometimes they don't. Rev first, then Windows. Rev first, then Windows. I think it doesn't matter which order we do it in. I think Windows Rev is fine as well. Because either way, we get pairs of 2 all the way to the end. And those all line up. Do we need the end, though? If we do this whole thing... Oh, Rev would give it to us in the right order, though. Rev Windows. I was kind of just hoping there was going to be iter reverse, but I guess there isn't. So we probably, I think Windows is going to be weird if we do it like this, right? What we really want is Windows mute. Which is going to be problematic. Iter tools. Windows mute, I think, comes from like a completely different crate, like lending iterators. That's what that is. So we could do the indices instead. I don't really need to deal with all of that. Man, you've been so close to finish, but you're running into a weird bug somewhere for an hour now. Your share one's fixed if you ever do. Nice. Are you also doing this implementation? That's awesome. I know you were saying earlier, you're the reason that we got on this track in the first place, but oh yeah, so long as both are double-ended. Sorry, I thought you were looking for something else. Yeah, it is double-ended, but we don't have. We need the window to read one and set the other, right? What is the actual? Now our root for each of the previous points, find the vector pi plus 1 minus pi. So end minus beginning. And the new position, pi, as the relative position of that joint along this vector. So we find the vector, and then we take the length of the bone, and we set it along that vector in that direction. So I think I'm going to use indices here. I want to kind of name these relative to what's being given. In 0 dot dot current positions dot length, right? I mean, I guess the thing that we could do is also we can current positions dot iter mute dot reverse with enumerate. And then we would need to access current positions in here. So it's a little bit awkward. Let's see, for I pause in right. So you end up with I and cur pause at the same time. Which gives us what I expect to be a borrowing issue. Right? So if we're going to try to access multiple things at the same time, this is always going to be an issue because we're taking that mutability through the vec. And we're also trying to access other members of the vec, which means that we really need to do the enumeration here. Which means that we need something a little bit more like this: 0 dot dot current positions dot length. Dot into iter dot reverse dot windows tuple windows. I guess we pull in iter tools tuple windows. Otherwise, we either pull in iter tools or we have to go nightly. Those are our two options until what did we call this? Inverse kinematics. Well, actually, do I have this in the workspace root? I don't even know. No, I don't. Yes, I do. Come on, Rust Analyzer. So we tuple windows, we get P2 and P1. These are the indices, not the actual things. So we can get current positions, get P2, and then we're getting the vector here, right? 2 minus 1 vector. I guess if I'm going to unwrap, I might as well just do direct index access. I don't know what I'm thinking. So let vector equals this. That's a vec2. And then we have the distance to the joint, which is current positions is just index 1, index 2. We can do index 1. I'm trying to match P1, P2 over here. I guess these can be P1, P2 if they're going to be written like this. So we have the vector. We need to get the bone length for P1. Right. So for all of these, we need to get this vector, find the new position along this vector for P1, which is the length in that direction, right? So normalize times length. Is that right? Xavier can probably correct me pretty easily. If we have a vector and we want to go a specific length in that vector, we can normalize it and then multiply by that length, right? Like this. Thank you. So we need to get the bone length for this index, which we have not grouped up together. So in this case, this will be interdescendants like nth, whatever, right? And the way that we're doing the indices gives us the correct index if we do interdescendants. No, it doesn't. Interdescendants not including the root is really annoying, actually, for this particular use case. Right, because we've got bone length here, and this is IK bones. We potentially need the root as well. We're using IK roots to find these roots. It's the easiest way to get these. I could build up the bone chain ahead of time. In the same way we're doing these transforms. Maybe that's the best option. Maybe I just shove them into that vec, right? Current positions, but also bone length. So this actually becomes the bone length, whatever the lengths. In this case, this is going to be root bone length. And this is going to be a theoretical bone length dot get. I guess unwrap or 0. Use a float literal. Yes, that's what I want to do. Add a reference here. No, I refuse. What is my little thing saying? It is saying that, oh, bone length doesn't implement clone. Bone length can probably implement copy if I'm being honest. Where's bone length? You're going to get a clone for now. I don't want this, I don't think. But it's fine for now. We never mutate bone length, so they can be shared references. Which means that this can probably all be right? And then that doesn't need to be like that. And then pause is last mute with the bone here. And then current positions dot 0 for that tuple. And then current positions P1 dot 1 dot 0. That's a really awkward like little thing to read there. So this is the new position. So then we do this. And then we theoretically have all of our changes, right? We haven't done the forward pass. Hilariously, I moved my comment down. Temporarily cache. This is technically the start of the forward pass, right? So there's current positions after, and we'll get current positions before. Just for kicks. Maybe have it implement dref2 while you're at it. Might also want to stuff the entity in that tuple to simplify the process of writing back the positions at the end. Yeah, maybe. You think another position should be used to subtract the direction length from? Hang on, I need to fix a shared reference issue. Well, it's cool that it theoretically is doing it. Why is bone length 223, 100? That's not our original length, right? All right, total length of the bones. Oh, we changed it. Okay, actually, never mind. I think that I forgot that we changed it. So now it's 323, which should be pretty accurate here. Yeah, 323. I forgot we changed the lengths earlier. But Xavier's saying, I think another position should be used to subtract the direction times length from. I don't think so. Maybe? Hang on. Find the vector and the new position, pi, as a relative position of that joint along this vector. So we have the vector from P2 to P1, and we are moving the point in that direction. And we have those in global space. So maybe you're right. Trying to think that through in my head. We have done end effector minus current position, right? Which gives us the vector like this. We have normalized this vector and then given it the length of the bone length for this other point, which should be the vector from this position, so we need to add them. Pictures may be helpful here. Yeah. I think it's an addition. Right, because the current position would be the current position dot 0 plus, right? So it'd be end effector plus the normalized vector times the distance. Which at least stabilizes. I think that that's correct, because if I'm looking at the world coordinates, these are all kind of fairly negative. The root is also negative because we haven't done the forward pass yet, I think. Maybe not. Can I add gizmos for the current positions? Yes. Yes, I can. You think it's a minus? I think you're right. Looking at so the root needs to stay roughly at 0. It shouldn't move that far off from what I'm aware of, right? So like 5034 seems much more reasonable than negative 400. And we still get a global position of like this is positive X, like 20 or 30 and negative 30. That looks like the right position to be in, right? So you're right on the negatives. Do you still want to see the gizmos? Because we're about to write them back, I think. Actually, we need to do the second pass. So let's do, I guess let's write these out as gizmos. Where is our gizmo arrow line? So this is going to be the theoretical new positions, which I think we can just do as a post pass, right? For current position, or for pause A, pause B in current positions, gizmos line, pause A, pause B. Is pause B bone length? That's because I'm not windowsing. I'll just name these A and B. Or I'm going to have totally messed it up. I guess this is an array when we do it like this. It's a slice, right? But I'm going to be honest. Since we've already brought it in, I heavily prefer having the strictly typed version here. When we get array windows stabilized, we'll start using that. But until then, I think I'm going to stick with iter tools, just because this is so much cleaner than just getting an arbitrary slice. It makes it much more clear that we expect 2 things here and not 15. So here's our IK system without the forward pass. Right? So if we go outside of this line, we can't reach it, which looks actually a little inaccurate, maybe. Or maybe that, no, it actually isn't inaccurate. I'm just lining it up with the arrowhead. That's, whoops. So when we do this, the root of our other thing moves, so we can kind of move this back and forth, which is interesting. So we've got like a primitive IK, and all of these positions are technically reachable if we do that. And if we go outside of the circle, it doesn't work anymore. I mean, that's cool already. You're right. The algorithm was not that bad. So let's comment that out for the moment. Spider legs. Comment that out for the moment. And we need to get into, I guess, the next segment of this. Just getting rid of a bunch of these logs that we aren't using anymore. So the question then is that this is probably more impactful when you have more bones. So we'll bump up the bone count in a bit here as well. So for each of the next points, so root is shifted from its initial position. Absolutely saw that using our gizmos. For each of the next points, pi from I to n minus 1. I to n minus 1. So in reverse direction is what they're trying to say? Like from edge effector to, no, from root to edge effector. So we're going forward. Find the vector pi to pi plus 1. So from root to next joint. And the new position as the relative position of the joint along this vector. Update new diff with pn minus t. Pn minus t is what we used up here, right? So theoretically, we do backward pass, we do forward pass, we set all the transforms at that point, and then we can choose to do it again. Root to end effector. First set the root bone position, then go to the root tip. Yep. Yep. So same code though, right? Effectively. Except in opposite direction. I feel like if I wrote this, if I had wrote this more reasonably, I probably could have written a function that does both and just requires you to pass in an appropriately sorted iterator. But yeah. That was P1 minus T, not Pn minus T. Yeah, that was the first one though, right? P1 minus T is the root. Update the new diff, Pn minus T. Pn is... There's no other mention of a diff, though, right? Oh, while diff is greater than tolerance. So this is our loop back up. So we get to do our loop after we set this. So when we set this, then we do our full loop. Okay. I feel like we're doing pretty good. Doing pretty good for, I think, what is the first, quote unquote, this isn't really a paper that we're looking at, but first algorithm implementation stream, we'll call it. Okay, so, well, it's not the first. We did collide and slide and other stuff, but yeah, you know. So basically the same thing overall, right? Current positions is really what we needed to do all that work. So basically all of this is the work we need to redo. So we'll call this backward pass, and we'll call this forward pass, right? And then this is not last mute, this is first mute. And first mute needs to go back to its initial position. So realistically, these calculations, we're probably going to do all the grab all the transforms, do all the calculations, and then put it back into the transforms much later. So we're actually going to construct this vec of current positions much earlier, I think. So forward pass. So we need first mute, which is just next. Is first mute even a real thing? I guess we're on the vec, right? Not on the first mute would be a thing on a vec. Yeah, perfect. First mute, expect bones list to have a bone position. This is not going to be the mouse position. This is going to be the original root position. So this is going to be translation equals transforms.get root entity unwrap. This isn't transforms. This is global transforms. Global transforms get root entity unwrap translation dot xy, right? And then this is root translation dot 0 or dot x and dot y, right? So we set the root back to its root, and then we continue. And then when we continue, we no longer need to reverse because we'll be going from the other direction, which is going to give us P1 and P2, which gives us the same logic except reversed, right? Pi plus 1. It would be fancy to write this in the same order and not change these identifiers, but I think I'm going to change the identifiers now and then generalize later if I want to. So this is 2 minus 1, and this is 1 minus 2. Right? 1 and 2. So the one that we're supposed to set here is find the vector pi minus p2 and the new position, which is the root position minus the normalized vector of the current position times its magnitude. And we set that as P2, right? And then we can update our diff, which is Pn minus T, which is the total length, the end effector minus the total length, so how far they are, and that gives us our diff. So we need to set diff, and this is the end of our loop. Pn minus T dot normalized, Pn why does that need to be normalized? If we normalize it, it automatically goes to 1. But the diff is the thing that we're using to actually stop iteration. Oh, pipe means length. Is it really? Is that what we used before? Oh, right. Yes. I think normalized is not right though. We need distance, but we don't need distance, not normalized distance. Normalized distance is a ridiculous thing to say, but you know what I mean. Okay, so for this loop, we get our total length and everything. We do current root position, end effector entity. This is our distance less than tolerance. So technically speaking, these are variables that we need to set earlier. Are they though? I think they are, which means that current positions kinds of needs to be way earlier, right? This can be all the way up here. This can just be like the first thing we do is calculate these positions. And I think that doesn't cause us any issues, which also means, well, total length. I guess we should do it after the total length here, right? At least like don't do all the work before we can determine whether we should do the work or not. And then this end effector situation is kind of what we need to do as a variable, right? Diff equals this. Followed by loop. And make this a break. And then diff is here, where diff is, this will infinitely loop if it never finds it. So hopefully it works. I guess we could count the iterations as like a failsafe and kill it after, 10 iterations or whatever, but we're full throwing it right now. So end effector. Is this the same thing? The end effector distance. What do we have here? We had root and end effector, and then we have end effector and total distance, right? If the distance between, why does that say P1? If the distance from the root to the, wait, P1, hang on. P1 is root, target position is the mouse position. So this is root to mouse position, which we used end effector for. Why did we use end effector for this? Shouldn't this be the root? Hang on. Given joint positions pi for 1 to n, right? The target position t and the distance between each joint for 1 to n minus 1. For 1 to n minus 1? I really wish they had just like used root and end effector as words here. Okay. Let me try this again. The T is the target, and this is P4. So they call P1 the root for sure, right? P1 is always the root. So this means if P1 minus T this is not the diff. This is the wrong diff calculation. What you doing? Just joined. Inverse kinematics. right now we're finishing up the 2D inverse kinematics implementation for the algorithm named FABRIK. So in a second here, after I fix my starting condition, we should be able to see inverse kinematics in action. Your implementation focuses mostly on the solve implementation, and you use an intermediate representation to abstract away from how you structure your skeleton and bones, etc. Nice. Yeah, I assume that as I move from this 2D implementation to like a real 3D implementation that works with armatures and real world bones, that stuff here will have to change. It's just a given in my mind right now. So this is saying root minus total distance, right? No, this is the, and we're using mouse position. This is also inherently anchored on world center, I think, because of this mouse position. Right, so this is the total length of all of our bones, which is T. If the total length is less than the mouse position, which works for us for now, we return, which is, I guess, not this, right? No, that is that. Sorry. The target position and the total length. This is the total length. This is the diff between the root and the target. Right. Sorry, let me just leave a comment here for myself. If the distance, if the total length of the bones is less than the distance required to reach the mouse, then you can't make it to the target. To do mouse position is relative to world center and should be relative to armature root is what I'm going to call this, right? Because right now its mouse position is a vector from the center of the world, and total length is just a length because our thing happens to be at root 0, 0. So this works, but this is not the correct calculation. So I need to fix that later when we start moving this around the screen or something. Yeah, works at the root, bone is at the origin. I don't know if you've seen the video where you made the robot to cheat in video games and had to use reverse kinematics to figure out how to adjust the arm holding the mouse. Is this something similar? I haven't seen. Yeah, IK chain root. You're right. IK root. I haven't seen that. Oh wait, is that the one where he like strapped a machine to his arm and made the arm move his arm? I don't think I actually watched that video, but I saw a clip or two. Yeah, I think that's the same thing, but I can't say for sure because I haven't watched that video. You basically pick the point and you're trying to reverse engineer how to get to that point with the amount of bone length that you have. And the term for that is inverse kinematics, which is why it's called IK. Okay, so otherwise the target is reachable. So set P1 as the initial root position. Find the distance of end effector from target. Okay, diff is end effector to target. That is correct. End effector. Oh, this is wrong. End effector is a vec2 from the regular transform, which is also wrong. And the current root position is also that transform, which we're no longer using. So these both need to be global, and it needs to be to the mouse position. Not at this point. At this point, this is just getting the end effector, which I don't actually think we use these anymore. So these both, or this needs to be global transforms in the first place. Right? End effector here. And then current root position is just not something we use at all, right? And then this is end effector to mouse position. Right? End effector global transform to mouse position. If that's less than the tolerance, then we stop. So here we do diff, and this is the correct diff. Right? You think it should be root bone to mouse position? It can't be root bone to mouse position. If it's root bone to mouse position, this will never happen. Because this tolerance is supposed to be small, right? And at the end, right, after we've done a backward pass and we've done a forward pass, the root is always exactly where it should be, and the end effector is potentially off. That's how we're ending the algorithm. So I think this has to be end effector to mouse position. Right? Because the idea here is we're trying to get the end effector closer and closer to that mouse position. And to do that, we start off by placing the end effector at the mouse position and then kind of iterating through to the root, and then placing the root at the correct position and iterating back to the end effector, right? So the real question is the end effector close enough or not? And that's what we're answering here. So it can't be the root. I don't think P1, like I know P1 is in here as root, right? But this is P1 target is greater than, okay, so this is the actual, this is not the part. So this is the part you're looking at right now, right? Of the algorithm. This is this calculation. These two are the same calculation, right? Just so we're on the same page. This calculation is this calculation from the slides of the paper. This is what I'm trying to look at, which is this. So the diff is what keeps our loop going or stops our loop. And the diff originally, what is B? I don't know. Anyway, find the distance of the end effector from the target. So Pn minus T is the diff, which is the end effector, and the target, which is this. Right, here's diff. If diff is greater than tolerance, in this case, we're doing less than so that we break. But yeah, I think we're on the same page. I think this is the correct way to move forward. They never use B again, ever, do they? Like, am I going nuts, or do they just never use the letter B ever again? They say set B equals P1 as the initial root position, and then they just never use B again. Oh, there's B. Now our root P was somewhat shifted from its initial position, set P equals B. Okay, so B is just like a hard root position. It's like a constant for us. It never changes. We just set it, the root position. Okay. With that all said, this should now be the algorithm, right? Aside from the fact that we need to set the end effector. And in this case, it's not going to be end effector to mouse position. It's going to be the end of the current positions dot last unwrap distance unwrap dot 0 dot, yeah. So the diff is there. And if I'm lucky, this won't infinitely loop. And if I'm unlucky, this will immediately infinitely loop. I seem to have been unlucky. Let's do bailout condition. Where name equals what? Cargo, Bevy, inverse kinematics. All right. Just a quick infinite loop. How could you implement an algorithm without an infinite loop? What is the tolerance? Need to increment somewhere. It is F32 epsilon, which is small. So let's do like 1. 2D, it's kind of like pixels. Let's start with 1. Well, I'm doing great, y'all. I'm nailing this. Still need to increment I. Did I really? Nah, man. Let's do this, just so I don't have to keep killing the process. Okay, and this is once again relevant, right? So we can set the diff and we can render this out every loop. And there's our problem. Well, I don't know if that's our problem, but this is all of our vectors, global positions, right? These are supposed to all be global positions. So this math is wrong, I think, is the situation that we're in. Because it never converges. So let's take a look back at what we're supposed to do. We know that the logic for the backward pass is correct. So it's just the forward pass that's an issue. The logic for the forward pass should be get the first position, get the global transform for the root entity, right? Because we haven't set any transforms yet. So the global position for the root entity should be accurate. So we set that here. Then we iterate over all the positions as tuple windows. So this is like 0, 1, 1, 2, so on, right? And the logic here should be that we get the vector from the current position. So is this supposed to be P2 minus P1? This is Pi minus Pi plus 1. So it's correct. And the new position of Pi plus 1, right? So this new position is the normalized vector times the bone length. And then this zeroes out for the last item, for the edge, I think, is the issue. I'm also setting current position P1 minus normalize. You think you should be bone length of the first bone? For each of the next points, I to n minus 1, so we're going from root to tip. Find the vector from root minus next, and the new position for next. Next is the relative vector of that joint along the vector that we just calculated. So we calculate the vector, right? P1 to P2. That gives us the vector. We normalize that vector. Where is our visualization down here? From P1 to P2, right? So we've got our root. We've moved our root. Is that our root move? Where's our root move? Yeah, this is our root move. So we move our root. Then we have P2. And we need to project P2's or P1's bone length to P2. Yeah, P1's bone length. You're right. So this is all 5 iterations. 1, 2, 3, 4, 5, actually 6 iterations. This is the closest we can get, I guess. Right? Because we only have the 2. So we can never actually get there. If we're in... Interesting that the joint flips. I feel like the joint flipping might be a bad thing, but this isn't on... Okay, so let me get rid of... let me get rid of I. Or maybe we bump I to 10 and we do this at the end. So just for the last one. So given a position, we end up with the root at the root. And we basically have all positions covered that can be covered. And if we are not out of range like this, which I don't know how to detect, by the way, I don't know how to detect that this is a problem. But if we have a position we can get to, it does stabilize. And if we don't, we kind of let it go for 10. The joint bending the other way is normal expected. Handling rotation limit for the joint probably comes later. Yeah, it's definitely not in this algorithm. Joint restrictions. So this is a successful implementation of the algorithm as far as I'm concerned. I do think that we need to, we have to have that cutoff because otherwise this will run forever, right? Where the mouse is somewhere that is effectively unreachable by the chain of joints. So we kind of have to like try our best and then bail. And I don't know how many iterations is good. Oh, the flip when the mouse crosses the 12-hour is not expected. Could you do one iteration per frame, or is that silly? We can do one iteration per frame. I think I would need to rewrite the logic, though. The only other thing would be we could implement stepping potentially. Yeah, I'm just thinking through it because it's a problem that comes up fairly often, if I'm being perfectly honest. The idea that we have this algorithm, right, which is at this point pretty messy, right? But 300 lines of code. The system itself is 285 to, we'll call it like 100. So we'll call this like a 185 line algorithm. Can be definitely chopped down. It doesn't need to be this complicated. This is just my first working implementation. But we would need to step this loop is what would need to happen. So to do it per frame, one step per frame, we would need the mouse to kind of be in the same position. It's not a silly suggestion. And I'll tell you why it's not silly, because there is a thing in Bevy called system stepping, which I think is in the ECS directory. System stepping. And it's not the first stream this has come up. So demonstrate stepping through systems in order of execution. And I actually don't know if I can hold execution inside of a system. I want to say no. But I could implement this as a system that does one step of the algorithm and then call it 5 times. You can do a run system manually, and that would work. So then we could have the input. We could have the input being our regular input and the output being like the next set of positions and stuff. You think the renderer should not be used for timing stuff, which is why it's actually silly. We wouldn't be using the renderer to time stuff. System stepping is a completely separate debug tool, right? It controls the execution of the systems inside of a frame. So if you want to, and these were individual systems, you would be able to like push the right arrow key and see each system execute and then look at the output of the next one on screen. So it's definitely not silly. I don't know. I don't think you can break inside of a function. That feels kind of weird. Maybe there's something though. I don't think so. I think we would have to break this up to be able to do it, which is also fine. It's just one of the reasons that I don't really use stepping all that much, because it would be really cool for examples. But there's a trade-off between how complicated it is because I made the visualization cool and how complicated the actual example actually is. Generators you can break one day when they're, you know, stabilized and given to us mere mortals. We also don't have async or anything, so hopefully we'll be getting some async stuff soon. It's 12:20. Cool. So I'm generally speaking pretty happy with this. So the one thing we can do is something I've done before is something like this, but changing the color of each of the debugs, right? Because if I render it every single time, this is all of the iterations. And it's hard to tell which one is which, right? But this is all of the iterations, all 10 iterations as we get to the point at which this actually works, which is very, very cool. The other thing I want to try is more. More. Where's our thing? Oh, applying the position to the real bone entities. Right. I forgot to do that. Sorry, I got so excited because of the visualization that I thought it was working. Hold up. Let's do the actual. Okay, so here we have current positions. Current positions is all of the individual positions that we need. We have a similar iterator, right? We have iter descendants in this case. So we need to do children, iter descendants, root entity, technically. But we're going to start with, what are we going to start with? I guess we do a simple subtraction and a simple sum for all the global positions, right? So for joint in current positions, this is vec2 and bone length. We don't need bone length. Global position, right? And then we children, well, let's do commands.entity, or we could do transforms. Transform weighing the options in my head right now. I think we'll set the root and then iterate. We again run into the problem of iter descendants not including the root, which is kind of annoying. So there's going to be like insert transform, right? During which we can current positions into iter, right? And this is let root new root position equals it.next dot unwrap. If this doesn't work, then we're in trouble. This is a new root position. So this is a vec2, which means that transforms.get mute root entity dot unwrap, because it has to exist. I guess the root entity never moves, right? Now that I'm thinking about it. The root entity here is always supposed to be in the same place. So we actually don't need to touch it, which is actually cool. Implementing an IK chain iterator might be useful and remove duplicated code. Absolutely. So we don't need this because that's the root. And then we can what is our iterator going to be here? Our iterator here is going to be something like, because we're assuming one chain, right? Children.iter descendants root entity dot zip current position, or it, I guess. For entity global position in, right? No bone length. So we have the entity that we need to insert on and the global position. And we need to keep track of the parent, I guess. I guess we can always, well, we have to keep track of it because it hasn't propagated yet. So let current root position equals transforms.get root entity global transforms.get root entity, right? Global transforms.translation.xy. This is the current root position, like the global root position. We'll unwrap this. There's a lot of unwrap in this code. We're just gonna futz with it for now. We'll deal with the error messages later. Vec2. So this is our current root position, right? Our current root position is a global transform that represents the root entity at the moment. The root entity for us does not move. So when we iter, this is the root entity that we need to do the calculation against for the first. Right? So let relative equals global position minus current root. Right? And this is the relative position relative to the parent. And then transforms get mute entity unwrap let mute transform equal transforms transform dot x equals relative dot x transform dot y equals relative dot y. Transform dot translation would be the thing. And theoretically, this updates all the transforms. We do need to set the current root position here. End effector needs to go. Yeah, I agree. And here's our theoretical situation. I think that this is correct, but the secondary transform is wrong. Okay, so current root position, right? The root is in the root. The next joint takes the root position, does global minus current position to get the relative from root of the joint, right? Current root position takes the new global. We set the transform to that relative. And then the next root is global minus current, right? There's a lot of stuff that needs to be handled later. Iter descendants will not work, Xavier says. Assuming the root bone is at the world's origin needs to be fixed. Yep. When the target is too far away, needs handling, it's just bailed out of in this algorithm. They don't handle it at all, actually. So we get to handle it however we want, if we want to do that. For example, we could just get the direction and stick everything in the direction in one pass. End effector needs to go. Yep. Handling non-uniform scale is also a to-do. Bevy in general doesn't handle non-uniform scale well. Why do we need non-uniform scale? They do handle it in this algorithm. Do they really? They just bail out, I thought. Right? Target is unreachable. Oh, okay. Find the vector t minus p1 and find the relative position of each point along that vector. So I just skipped it. Yeah. But that's easy enough. That is like get the bone position and stack the bones in the direction. I think that's pretty trivial. I think I'm more concerned about whatever I'm doing here to set the transforms. Because currently it looks like we get the right actual vectors. If you think about the bones, the long bone is the one to the left here, and the bone to the right is just offset from the center in the wrong place. So it should be offset from the root. Or not from the root, sorry, from the second bone, and it's not. And you can see, like, I can't draw on my monitor and not move the mouse, but the long bone is the first bone, the short bone is the other bone. So the question then is, what am I doing wrong here? The root position we don't touch. We zip these two. The relative position of the current should be the global minus the current root, right? I'm going to have to go through that and print it out and debug. Setting the transforms with the correct rotation is highest priority. Yes. We aren't currently setting the rotation, which is fine. We're just using the gizmos. But the rotation can be calculated, I think. Global position minus current root position equals global position, transform, set it equal to these x and y's. So the global position minus the root before it should be the relative, right? Or am I just wrong? Right, global transforms, iter descendants, root entity zip. Here's our entity. Here's our global position. The relative is correct. So what's wrong with the, is it all relative to the current root? Do I not need to, am I doing extra math? I'm doing extra math. So this is working. In which case I want to draw the gizmos. So the root, so global transform, get root entity, wrap, unwrap. I feel like something like this needs to happen. So I'm going to leave the comment there, but we'll see. Let's do the arrows. I guess this is for current position, right? So we just get to iterate here because we already have everything correctly. So here's our gizmos before we get into actually doing like taking ownership of that vec. And here is our gizmos in action. It's the name of my next book. If we go outside, it kind of just stops because we stop. If we go inside, I don't think inside is handled by the algorithm. Maybe I missed that too. But outside should definitely reach fully like straight. But otherwise, this is very cool. This is like working. And the thing that I want to do before we end here is many bones. Which means maybe a lot of tiny bones. Let's just do a full dupe here. And let's do something a little bit shorter so we can get more of these bones in. I guess like all the bones can be the same distance. It's totally fine. Make it easier to actually do a bunch of them. Too close to the root to be attained is handled by the algorithm, but in this case, the loop never exits except by limiting the number or iteration. Too close to the loop to be attained is handled by the algorithm. What do you mean by handled by the algorithm? You think the FABRIK right? Target is unreachable. I don't think so. Oh, you mean the IK is calculated correctly? Okay, yeah. I think the only way we get out of there is, like you said, by bumping it. We just have to pick a number of iterations that we're happy with and then let it go. And I think that over time, like frame to frame, even if those do actually end up being different or like largely different, that will accumulate and stabilize over time. Okay, so let's just call this joint position, right? Let's just say all the bones are length. Like all the bones are 30-30, whatever length that is. So we end up with a root with a bone length and a position offset that is the bone length offset with another bone length. You suppose there's a potential difference between IK for scientific purposes and IK for games. It doesn't really need to be perfect for the latter, optimized for speed versus accuracy. Absolutely. I think there's a lot of cases in games where you don't need a scientific, or I guess somebody put it earlier as NASA level of accuracy. We're not landing spaceships, we're pushing pixels. So doesn't really need to be super accurate. And also, I think if we were trying to be super accurate, there might be other algorithms that do different things that might be better for different use cases. Okay, so what I want to do is I want to take this and I want to drop it here like a couple of times. These are all joint one. FABRIK is as fast as it gets. Interesting. Here's our IK. Working with a bunch of bones. You think the loop until tolerance is achieved is a Gauss-Seidel method, which is simple and fast for low tolerance. Okay, cool. I've heard those words before. Are we setting this circle based on the length of the actual stuff? This is cool. I'm excited about this. I think that my intention is to really only use this for 2 joints, for which I think there's actually an analytical solution that is not iterative like this, but it's very cool. You also have your example up message above, which is running in 3D. Nice. Same solver message at XPBD. If you sent a link, it will not post in chat. So nobody will see a link if you send a link. If you want to quote unquote link to a repo or something, you can specify like the GitHub user and repo or whatever, or you could send it in the Discord, which is hopefully my bot is running. I never check that thing. And you can post a link there too. Pluruto, FABRIK, Bevy prototype. Okay, let's see. We've got ours working, so I would love to see somebody else's. OBS. Sweet. That's sick. Cargo run. You put everything in the plugin then? Let's see. You defined each bone and set the length. Some bones are changing length. Skeleton max reach. So this is the total length. Compute joint positions. This is our loop, right? The same thing that we were doing. You're accumulating rotations and lengths, which is probably good for 3D. Result, joint positions. This is our current positions, target reached, whether you pass the diff or not. Cool. Here's your bailout condition, bones length, compute joint positions. Nice. Max iterations, same thing that we're doing. Next joint, normalize, times skeleton bones length, magnitude times, yep, this is the same thing. Backward reaching. You think this is forward reaching? I feel like we went back and then forward, right? Let's see, tip joint. I guess your edge effector is tip joint. I think in the algorithm that's considered backward. So you have these labeled. I think you have these labeled wrong. I might be wrong. We can play the thing again. People are talking about it in chat. Here's full screen. I mean, I feel like it would be hard to tell with the whole thing rotating. You think the algorithm paper have wrong back forward naming? Really? I thought it said backwards was from tip to... We inverted the names. Did we really? Perform forward and backward pass. Forward and backward pass. I guess it doesn't label them in this slideshow, so... we didn't actually read the paper. We did a derivative source. And I just kind of picked backwards. Yeah, this doesn't actually specify which one is forward and backward. So I guess it doesn't matter. Yeah, first pass is the backward pass, in your opinion. I think that matches for me too, obviously. I mean, I chose that as the way I named it. I wonder what the actual paper has. Right? It says this is the paper. Here's the paper. This is what I was intending to read earlier. But the slideshow turned out to be pretty good. They have a full implementation here. So input, output, position, target is reachable, thus set B. Check whether the distance between is greater than tolerance. Stage 1, forward reaching. They use forward reaching for tip to root, which feels weird. Yeah, forward is from root to tip in my mind too, but it's not in this paper. So they actually have the correct naming in their repo because the forward and backward reaching are relative to the edge effector, not the root, according to the paper anyway. Yeah, a chain can be built for each end effector by moving back through a skeleton, going from parent to parent until the root is reached. So they do iter ancestors to get back to the root. By definition, in the IK problem, the root joint is assumed fixed, but methods can generally cope with the translation of the root. So yeah. The other thing we need to do in our example is move our root around a little bit and see if it still works. And then this sets us up pretty well to do potential spiders on a future stream. Not today, because we've done 4 hours today, 5 hours today already, but cool. So for anybody who's still hanging out after 5 hours of inverse kinematic implementation, where's my, there we go, Bevy examples, okay. I might clean this up a little bit, but generally happy with this. Went in today with really no understanding of the algorithm or IK in general. Only what I've heard through like random YouTube videos and stuff, obviously, but very cool that we were able to get this to actually work. Still a to-do on fixing like external, so this should actually pin to the edge. But overall, this is pretty cool. I'm excited to move this into 3D too. You say rotation is still a mess. Rotation isn't being done currently. But yeah. Because we aren't rotating the transforms currently. How do I frame this? I'll put some meshes on here rather than doing gizmos, and then I'll work through like rotations and stuff. You've put comments in your implementation relating to the difference between 2D and 3D logic. Sweet. I will look into that too. Thank you for sharing yours as well, and allowing me to kind of bring it up on stream and look through it. It's very cool to see like another implementation after spending, 4 or 5 hours working on one. Because now it's like, you can actually read this and know exactly what you were talking about when you put a whatever in this place or that place. Cool. That's it for stream for today. Thanks for everyone for hanging out. I'm going to go get some food and stuff like that. We'll stream tomorrow morning, probably more Bevy stuff. So maybe spiders tomorrow. Who knows? And that'll be it for the day. Thanks for hanging out, y'all.